Esteemed scholars, welcome. I know that you are having a short time with the videos on bearings. This afternoon, we are going to introduce yet another very important topic, and it's called inequalities. In the meantime, don't forget to like our videos. Don't forget to share them. And then, please continue to subscribe to our channel. Now, let's look at inequalities. Inequalities is from two words, a prefix in and a root word, equality. Of course, you know that the state of two things being equal is what is called equality. So when you place the in as a prefix now before equality, you will get a negation of equality, which is known as inequality. It is therefore the state of two things not being equal. The state of two things not being equal is called inequality. Inequality. So, if two things are not equal, how do we relate them? How do we show the relationship between them? We usually would do that using the signs or symbols of inequality. And there are four signs or symbols of inequality with their unique meanings and unique interpretations. Signs of inequality. Signs of inequality. Let us tabulate them. Here we have serial number. Here we have the sign. Here we have the meaning of the sign. And in the fourth column of the table, we provide a further remark. The first one is this. It's like folding your left arm, and it is known as less than. Less than. What type of inequality is less than? It's a strict inequality. It's a strict inequality. Then we go to the second sign, less than or equal to. Less than or equal to. What type of inequality is it? It's a general inequality. General inequality. Then we go to sign number 3. It is folding the right arm. When I fold my right arm, I'll get this sign, and it is known as greater than. Again, it's a strict inequality. A strict inequality. And finally, we have the fourth sign, which is greater than or equal to. Greater than or equal to. Again, it's a general inequality. These are the four signs or symbols of inequality. Let us further explain them. For example, it's possible to say x is less than 3. What it's saying is the quantity x is not up to 3. So it means that a part of the set of numbers that make up this x, 3 is not a part of it. That's what makes less than a strict inequality. It is telling you that this value here, 3, is not a part of the solution set. So, when you have, for instance, x greater than 3, which is another strict inequality, we are saying x is an entity that is more than 3. So, as it were, 3 is not a part of the solution set. That is what makes greater than a strict inequality. The value on the right is not a part of the answer. But that is not the same thing as having s less than or equal to 3. Here, we are saying s is an entity that is either equal to 3 or not up to it. So 3 is a part of the answer, is a part of the solution set. That is why we call it general inequality. The entity on the right is a part of the answer. It is the same explanation that goes for s greater than or equal to 3. Here we are saying x is an entity that is either equal to 3 or more than 3. So 3 is a part of the answer. Because 3 is a part of the answer, greater than or equal to becomes a general inequality, because the value on the right hand side is a part of the solution set, is a part of the answers for that inequality. So when we have questions on inequality, what do we do then? We solve them like we solve ordinary equations. For example, in solving ordinary equations, like terms are collected. Like terms are collected when solving inequalities. In solving ordinary equations, both sides are usually divided by coefficient. The same applies to inequalities. There are only 2 extra cautions that are taken when working with inequalities that we usually don't pay attention to when working with equations. What are these 2 extra cautions? Number 1, multiplication of an inequality by a negative constant reverses or changes the inequality. What's the meaning of that? If an inequality were less than, the moment you multiply it by a negative value, say -5, it will change to greater than. The second caution is, if you divide an inequality by a negative constant, the inequality sign is also reversed. That is, if there is an inequality and as part of my solution, I am made to divide it by a value, say -1 or -2 or -3.5, automatically the division of that inequality by that negative value will reverse the sign. If the sign were greater than or less than before, the moment I divide both sides by that negative constant, the sign will change to less than or equal to. There are the two extra cautions that you must take in working with inequalities. Multiplication by a negative constant changes the sign, and division by a negative constant also changes the sign. Otherwise, all other algebraic processes that I apply when solving equations are also applicable to solving inequalities. And it's usually very easy. You will see it through examples in a moment. Finally, I said just now that s greater than 3, for example, or s less than 3, for example, or s less than or equal to 3, or s greater than or equal to 3 are solution sets. What is the meaning of that? They are a set of values. That therefore presupposes that the solutions to inequalities could be represented on number lines. Or line graphs. What are number lines or what are line graphs? They are simply the x-axis carrying an arrowhead. Number lines or line graphs are x-axis carrying an arrowhead. For instance, when you are dealing with greater than, the arrow will face the right. When you are dealing with less than, the arrow will face the left. When you are dealing with less than or equal to, the arrow will face the left with a shaded boot. But when you are dealing with greater than or equal to, the arrow faces the right with a shaded boot. So every time you draw a number line and the boot of the arrow is not shaded, it means that the inequality is a strict inequality. But if the boot of the arrow is shaded, it means that the inequality is a general inequality. Finally, before you can draw the number line, you must ensure that the entity which is the letter is on the left-hand side of the inequality and the constant value is on the right-hand side of the inequality. If it is not so, you must rearrange. Ensure that the letter is on the left and the number is on the right before drawing your number line. You will see that in the few examples that we are going to take. I am very sure now you now understand the concept of inequalities. Esteemed scholars, don't forget to like our video, don't forget to share them, and don't forget to subscribe. Esteemed scholars, welcome. Thank you for liking our videos. Thank you for sharing them. And thank you for subscribing to our channel. We want to continue with the discussion on inequalities. And we are looking at linear inequalities in a variable. Don't forget that we have said the processes for solving inequalities are the same as the processes for solving equations, except that we need to take two additional cautions, which are when you are multiplying by a negative constant, change the inequality sign, or when you are dividing by a negative constant, change the inequality sign. Let us see how these work via this example. Example 1. A. Solve 2x minus 3 greater than 7. B. Illustrate it on a line graph. The first question is to solve it. 2x minus 3 greater than 7. The first algebraic process to apply is to collect like term. Minus 3 is a like term to 7. Take it to go and meet it. That will give us 2s greater than 7 plus 3. When minus 3 crosses the inequality sign, it becomes plus. And that will give us 2s greater than, what's the value? The sum of 7 and 3, or what's the value of 7 plus 3? It is 10. Now we have a coefficient 2. It is positive. We are going to use it to divide both sides. Because 2 is positive, using it to divide both sides will not affect the inequality sign. So 2 will cancel 2, leaving us with x on the left, and then on the right, 10 divided by 2 will give us 5. So the solution to this inequality, 2s minus 3 greater than 7, is s greater than 5. Therefore, s is greater than 5. Now to the second question, B. We are told to illustrate the solution of 2s minus 3 greater than 7 in a line graph. So we have the line graph. The line graph. Don't forget that we had established that the line graph is an x-axis bearing an arrow. Of course, a typical x-axis will be calibrated or graduated. Make sure that the graduation or calibration incorporates the value, the constant entity in your solution to the inequality. The value is 5. So I'm going to graduate this x-axis so that at least I can get 5. Therefore, we'll begin with, say, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7. We may stop there. Now, the boot of the arrow will sit on 5. Here is 5. It will sit on 5. It won't be shaded because greater than is a strict inequality. And finally, greater than faces the right. So the arrow will face the right as long or short as we want. This is a number line or a line graph representation of this inequality 2s minus 3 greater than or greater than rather 7. You would agree with me that it is an extremely easy stuff. And so it's nothing to worry about. Just the same process as solving linear equations. We are going to look at another one shortly, but don't forget to like our video, don't forget to share it, and don't forget to subscribe to our channel. Thank you. I'll see you in the next video.